Hello, gentlemen. It's Mr. Kilpatrick. Sorry I can't be with you in class today. I'm going to go over break-even word problems. So break-even word problems are going to have a couple ways that you can see them. One could be just a basic business problem where you've got some kind of business that sells a product, so they generate revenue from that. But in order to create that product and sell it, they have some kind of expense. And those expenses could be a fixed expense, like something that you have to pay no matter how many units you sell, and also a per unit expense. For example, if I'm going to sell t-shirts, I have to buy those t-shirts first. So I maybe pay a certain amount for the t-shirt and then I sell it for an increased amount. So I'm going to have expenses and revenues. In our break-even equations, we'll have one equation where we have the expenses, and then we'll have another equation where we have the revenue, and they'll both be in slope-intercept form, so they'll look like y equals mx plus b, and we'll set the two expressions equal to each other. So we did this a little bit before using just one variable. Now we're going to present it with two variables, and I think it'll just be a little bit easier to set up and then solve. The other type of break-even we could have is where we have two different, a comparison of two different plans. For example, maybe I go to I could join one gym and it has a certain initiation fee and then a monthly cost, but another gym might have a higher initiation fee but a lower cost. And I could write two equations, solve them to figure out when the two costs would be the same. How many months I'd have to be a member for the cost to balance out. So let's take a look at a couple of these examples. So we've got Daryl. He's got an accounting firm. He pays $2,400 to rent office space and equipment. For each tax return his firm processes, he must pay a junior accountant $55. But then he charges customers $85. How many returns must his firm process in order to break even? So you can see that this $2,400, that's a fixed expense. He's going to pay that no matter what, no matter whether he processes 1,000,000 returns or 0 returns. He has to pay that money. And then we have a per unit expense, $55 per return. If we look at how he makes money, he charges customers $85 per return. Usually there's not a fixed amount that you get for your income. Nobody's going to give you something for nothing. So like all word problems, I'm going to define some variables. How many returns? So X will be the number of returns processed. Number of tax returns. And Y is going to stand for two different things. In one equation, it'll stand for the expenses. And in the other equation, it'll stand for the revenues. Okay, so he pays $2,400. So his expense is going to be $2,400 plus 55 per return. That sounds like a slope. So if he processed no returns, he would only have to pay $2,400. If he processed, say, 10 returns, he'd have to pay $2,400 plus $550. Now, there's only one way he makes money, $85 per return. And that's our systems of equations. Since they're both in slope-intercept form, I would use the substitution method. 85x equals 2,400 plus 55x. Solve that. I get 30x equals 2,400. Do a little arithmetic. X equals, I believe, 80. So he will break even. His income will cover all of his expenses on the 80th return. If he processes fewer than 80, he's going to be losing money. If he processes more than 80, he'll now start to make money. Some of you, as you looked at this, may have realized, hey, he's making $30 per return. You may have automatically subtracted the expense per return from the income per return. I would ask you to avoid doing that. Have the two expenses and incomes, have them separated into two different equations. Let's look at another example. There are two pools, Pool A and Pool B. Pool A has 2,500 gallons in it, and it's leaking 15 gallons per hour. Pool B only has 1,000 gallons, but it's pumping in 100 gallons an hour. When will the two pools have the same amount of water? Think of this as a comparison of plants. In this case, it's a comparison of pools. When we're dealing with hours, so X will be number of hours. The time is determining the volume of water, so Y can be number of gallons. And we'll write an equation for Pool A and a separate equation for Pool B. So Pool A has 2,500 gallons, and it's leaking, it's losing 15 gallons per X per hour. Whereas Pool B only has 1,000, but it's gaining 100 per hour. So that's our system. Again, I would use a transitive property, use substitution. 2,500 minus 15x equals 1,000 plus 100x. Move gather all the x's on one side, all the constants on the other. It looks like I have 1,500 is equal to 115x. Divide both sides by 115. I'm going to need a calculator for this. And it's not going to be a pretty number, but x equals 13.043. I'm just going to write all the digits I see. I know my calculator's rounding it slightly. It's going to take approximately 13 hours for the two pools to be equal. If there was the follow-up question, how much water is in the pool when they're equal, I would simply plug that 13.04 number in for x in either of the two equations. But the problem is only asking me when the two pools will have the same amount, so I don't even need to answer that further question. Okay, so that's one type of system of equation application, break even. So we've gone over the other two, but I'll try to make a video for you for those as well, and you can check those if you need some extra help. Thanks.